Hi everyone, can you hear me? Magnificent. Okay, so as the title says, today we're gonna work a bit on Kakarot, the ZK-EVM written in Cairo that Abdel started a few weeks ago, and we implemented quite a few opcodes. And we're gonna walk through it. So this is the one. Okay, so first we're gonna go here on Kakarot, the GitHub repo. I'll send the link. Tell me if it's big enough or if it's too small. But okay, let's check the README. So there are a bunch of stuff on how to set up the environment. This is a GIF done by Abdel. He really likes them. This is the number of supported opcodes. So you can see we have 87% of the opcodes that are supported. Now it remains probably the 13% hardest percent. There's a bit of explanation on how it works, but we don't really care. And here are the contributors. Okay, so let's open the repo somewhere. Okay, using Tmux because Ben loves it. Okay, so let's go into the repo. Let's check what happened. Okay, and today we're gonna work on the full upload. But first, a little walkthrough on how everything works. Oh, Danilo. Never doing anything else than Kakarot, I see. Okay, so how it works precisely. Tac. So here is like Kakarot, like the external file, because right now Kakarot is a smart contract that we can deploy on StarkNet. And here comes Abdel. Hello, Abdel.
Hey, Lucas. How are you?
Good. I was walking people through Kakarot, but if you want to speak about it, feel free to do it.
Yes. Yeah, I can say a few words about the project. So basically, Kakarot is a ZK-EVM written in Cairo. So there are multiple types of ZK-EVM. For people that are interested in those types, I suggest to read the article from Vitalik. Maybe you can share the link, Lucas. Let me send it to you. It's a very interesting article, and it presents the different ZK-EVM types. Basically, there are four main types, type 1, 2, 3, and 4. And basically, the TLDR is that the lower the number, the closer to Ethereum compatibility it is. And but the less performant, and the higher the numbers, the less compatible with Ethereum, but the more efficient in terms of ZK proving and this kind of stuff. So this is interesting because depending on the needs, you may want to have more compatibility with Ethereum. Why? Because you can use existing tooling, for example, I don't know, debugging tools or any static analysis tooling or stuff like that. And you can leverage from all the existing tooling from Ethereum and also reuse as is existing bytecodes. But if you want to focus on maximal efficiency of the proving system, then you may want to have a higher type ZK-EVM, or you may even want to not have EVM compatibility. And this is basically what we propose with native Cairo. The promise is to have the maximal efficiency of the underlying proving system. And but for people that do want EVM compatibility, it might make sense to have this kind of EVM compatibility. So that Kakarot is, we aim to have a type 3 ZK-EVM. So basically, this means strict EVM equivalence minus some changes like no support for the precompiles, for example. For what are precompiles? So in the EVM world, you know, there are some opcodes. Basically, for example, add is an opcode to do an addition, multiplication. So there are a bunch of arithmetic opcodes. There are some system opcodes, etc., to do call to other contracts. And aside from those opcodes, basically there are 142 opcodes in the EVM. And aside from those opcodes, there are also some special system contracts that are called precompiles that are not run in the EVM world. And they aim to provide a specific function, like, for example, signature verification, elliptic curve pairing, stuff like that. Or other hashing algorithm, and they are run actually in native code. So for example, if you run get, for example, so the Ethereum execution client written in Go, then the precompile will be written in Go. If you run a client written in Rust, the precompile will be run in the native code of the client. Those precompiles are hard, very hard to implement in Cairo, and generally in a proof system world. So this is why when you implement a type 3, you don't have to implement those precompiles. But other than that, you have the full EVM equivalence. So this is what we aim to do with Kakarot. And Kakarot has a very special and unique architecture because it actually runs as a smart contract on StarkNet, and the smart contract contains the logic to run an EVM interpreter. So this is very powerful. This is a kind of inception where you have a smart contract that runs a VM that is interpreted by the Cairo virtual machine and generate proofs for the execution of the EVM bytecode. That means that you get a ZK-EVM. So it was more a showcase to showcase the power of Cairo, actually, because if we can do such powerful and such complex stuff like an EVM with Cairo, that means that truly this is Turing complete and you can build anything you want with Cairo. We will never get the performance of native Cairo for sure, and not even close, and this is not the purpose, but first it is a very powerful showcase of that. So to put stuff in perspective, if you want to build a ZK-EVM from scratch and you don't have Cairo, basically you have to build manually all the circuits or the algebraic intermediate representation for each opcode, etc. And this is very painful. And like all projects that are building a ZK-EVM, it takes a very long time. Basically, they started more than a year ago or even 2 years ago, and some are not even at the point where we are at with Kakarot. So this is the perfect showcase of the power of Cairo, because we can do that only because of the power of Cairo. This is truly the message we want to pass with Kakarot. And other than that, it's exciting, and we want it to become a community-driven effort. And actually, it starts to really be mainly driven by external contributors. I guess we can talk a bit more about that later, but this is huge to see the traction around the project and the engagement from the community.
Well, thank you, Abdel. I think you have a great overview of what Kakarot is. And now we can walk through, like, technically how it works. So basically what we need is that we need the bytecode, because like it's an EVM interpreter. So we need the code, the bytecode, and every byte will be a felt. So the full code, the full bytecode would be like a felt array with all the opcodes. Then we have the call data for the function call. And that we don't care, is for like the test. And so we'll execute this bytecode. So we go into this function and we will generate all the instructions, because basically what we need is to have all the opcodes in Cairo. So what we're doing here is that we have all the functions for that, which are somewhere around here.
In instructions.cairo, yeah, exactly.
And here we save all the functions code offsets, and we map them to the opcode. So for example, the opcode 1 corresponds to the opcode add, and we save the code offsets in a mapping. So when we call the opcode 1, it will go in the mapping, check, oh, opcode 1, let's get the code offset. It will get the code offset of exec add, and then it will call add. This will be done here in the run function. So this basically it just creates an execution context because we need it. The execution context will contain everything we need to run the smart contract. So the nested call depth, actually we need this for the call opcode, which we will finish to implement here. Here the parent is the same thing. It's a pointer to the parent context. So when we have nested calls, for example, contract A calls contract B, there will be a nested call, and we'll need to fetch the old execution context once the call is finished. So we need this pointer. Then the code. So as I said, it's a felt array, so we need the bytecode. Call data, same, it's a felt array. Program counter, we need it to keep track of where we are. And if the execution context is stopped, basically every run finishes with like the 0 opcode, which is the stop instruction. Return data is also an array, and it's the data that the functions will return. Are you raising your hand up there? Yeah, okay. Please talk.
Yes. I didn't want to interrupt you. Yeah, basically, also, why you explain, sometimes I may jump and say about the challenges we got and what we learned, and also some useful contributions that people that are listening could jump into. And I'm thinking about how we handle bytes, actually. Because for the moment we have a naive way of dealing with bytes. So in the EVM world, we deal with bytes. A byte is an integer value between 0 and 255, and that's great. You can manipulate byte array, etc. On StarkNet and in Cairo, you have only felt, and felt is an integer which is a maximum to a power of 251. That means that in theory we could store up to 31 bytes into one felt. So we don't do that for the moment, and it's an issue because actually we waste a lot of memory, and memory is an important resource when you want to prove, because a number of variables affect drastically the performance of the proving system. So if someone wants to experiment and implement some more smart mechanism to represent bytes, like for example felt packing, like for example we could in one felt store 31 bytes, and then we will need some useful functions to manipulate that easily, because we don't want to introduce a lot of overhead in terms of code complexity. But yes, that would be a great thing to do and to experiment if you want to contribute.
Yes, we're looking for the community to work on it. So if you want to work on this, please do. Yes, we're from France, but yes, if you want to work on it, and if you have some ideas, you can talk with us.
That, does this question mean that we have a dirty accent or something like that?
No, no, I think it's because of the view behind me. He saw like the Eiffel Tower. But yeah, so yeah, if you want to contribute, please do. We need you for this. We want to step out of Kakarot. We want it to be a community effort, or well, we want to outsource it. Um, Rosemi, yeah, if you want to make it efficient, please do. You have the link to the repo. You can check the issues. You can work on some issues. Just need to coordinate with the others, not to work on the same thing. Um, but it would be like really cool if you guys work on it also. Um, yeah, and so coming back to the execution context, so the stack, because the EVM is stack based, so you got your stack and you just push some stuff on the stack and pop it and blah blah blah, regular stack, and the memory which works weirdly, but it's just a memory, and then specific to the EVM, gas used, gas limits, intrinsic gas cost, and then the StarkNet address and the EVM address, because the architecture is that we want to deploy every EVM contract as a StarkNet contract. So, for example, you have an ERC20 written in Solidity, then you will deploy uh, a contract on StarkNet that has a view that is called getCode, and that will just return all the bytecode of the contract. Uh, as Abdel said, it's not optimized, and we're looking to optimize it. But for now, we're just moving quickly to have like a real POC. But this will be improved. Yeah, that's how it works. So we need to map the StarkNet address to the EVM address, because we need to interact with StarkNet, and we need to have the EVM address to know what contract we're calling. Okay, so now we have the execution context, and now we will run the bytecode. So the run function is recursive and will run all the bytecode until it sees a stop opcode. So it will decode and execute the instruction, and basically what decode and execute does is just call the function using this function, which is really hard to use, and actually like Abdel had lots of trouble making this work, but now it works perfectly. So thanks, Abdel. And basically what invoke does is that it gets a code offset and it calls the function at the code offset, but you need to prepare the arguments and you need to parse back the arguments that you receive. So this is why it's quite hard to use. And yeah, so basically like that's the high level scope. And what an opcode looks like, let's check add. So add is here. And so what add does is written here on this wonderful website, evm.code, and you can see that it pops two elements, A and B, adds them together, and then it pushes the result on the stack. So that's exactly what we're going to do. So we're popping two elements, A and B. We're adding them together, and then we're pushing the result on the stack. So we're using uint 256 because one word in the stack is 32 bytes, and in Cairo we're limited to 31 bytes. So we have to use uint.
Yeah, maybe you can explain why we implemented the pop-end function because it is an optimization trick, and this is very interesting. And it shows also the difficulty when you work with Cairo and the fact that memory is immutable. So you have to do some tricks like that to optimize. So I think it's interesting if you can explain that.
Yeah, sure. So basically in Cairo, the memory is immutable and a stack is not immutable. You can push things and pop things. So if we push something, no, if we pop something, we are, no, I need to check. I think it's when we pop something, we're copying, no. So when we push,
yeah, it is when we pop
the,
that we need to.
yeah, so okay, so when we push something, we don't copy the full stack, we create another one, but with the new element number, because the memory is immutable. So no, it's here. So we can't just rewrite only this property, so we need to create a new one. This is fine because it's not a lot of steps, but when we pop something, we remove something from the stack, we can't actually remove it. Like memory is immutable, so we can't just delete it. So what we have to do is to copy the full stack without the popped elements. So if we have to pop like 3 things, we would need to copy like thrice the stack, which takes a lot of steps and a lot of memory, and we want to mitigate it. So we just added the pop n function to avoid like replicating the stack millions of times. Yeah, okay. Okay, so here we popped in, and we didn't like bother reversing what's popped because it would have costed like a few steps, and we want to optimize. So we're using this. And yes, we're using uint 256 because the stack uses uint 32 bytes. So, okay, we got the result and then we push it, and then we have to create a new context because we modified the stack. And as I said, memory is immutable, so we need to create a new context. And also we modified the gas. Okay, so basically that's a simple opcode. And then we have tests. Tests are the funniest part. And I have conflicts. Yay. So this is like the result memory, the result stack, and the bytecode. So the bytecode is just like opcodes that are chained. You see here, you have 60. So 60 is push 1, so it will push the first, like the next value in the bytecode. So here it will push 42 in hex. Here it will push something else. Here it's 52, so it's an opcode. 52 is mstore, I think. Yeah, mstore. So it will store a word at a precise offset. So this is the offset. This is the word that we want to store, and it goes on. So what I would want to do today is to finish the call opcode that we started with Abdel.
I like the message at line 18.
Line 18. Yeah, so he fucked up the CI. So yeah. We had to fix it.
We were in hackathon mode to give me some excuse.
Yeah. So yeah, we wanted to go faster. There were some trade-offs that we took. Anyway. So let's go back to the call opcode, which is not here. Where is it? Here. Yeah. Oh yeah, we had to put it here because we had some circular imports, which is not fun to deal with. So we went hackathon mode and just put it there.
Yeah, because the problem is that we wanted to leverage because basically to implement the call opcode, what you have to do is to invoke the code of another contract. And typically what you want to do is you get the bytecode of the call contract, and then you run the exact same logic that you did to run the bytecode of the caller contract. This is why we wanted to leverage. We were thinking like, okay, it's just the same thing as executing the caller contract. Just you take another bytecode and you have another execution context. And because we wanted that, we wanted to be able to run the main run function, but because of our architecture, we have the main function, which is in the interpreter that has dependencies to the specific opcode function, but you cannot have a dependency in the other way because it creates a circular dependency. Yeah.
Yeah, and it's really not fun. And here you'll see a really unfun rebase also, because we removed all the hints to be able to deploy on testnet and to be able to use the Rust VM, which does not handle dynamic hints for now. So we want to switch to that. So that's why there's no hint. And that's why we'll need to rebase now and not have fun because there will be conflicts at every step. Are you all on Telegram? Yes, we are on Telegram. Maybe
you can share Kakarot, Kakarot
yeah,
Telegram
I don't
group.
have the right to do it, but if you send me the link,
yeah, I can send you the link.
Would be awesome. Okay. So.
Okay, I put it in the chat.
Cool. Feel free to join. Putain, j'arrive pas à copier. Ah. Yeah.
Okay.
Okay.
And I will send you the Twitter as well.
Yeah, feel free to join and check the repo.
You can post a lot of Goku memes as well. Yeah.
Yeah, we don't have moderators for now in this group.
Yeah. Okay.
Don't spam it too much. Okay. Okay, so this was.
Yeah, by the way, we also want to do some cool stuff for contributors. Like likely we will do some kind of SBT, southbound token, to reward contributors. And basically, there will be some rules, like for example, the number of PR you submitted into Kakarot, and then maybe we will have multiple levels. And for example, if you want to do something funny, we can have the different level of Goku, the different transformation. For example, you submit one PR, you have the normal Goku NFT, and then you submit 5 PR, you have the Super Saiyajin Goku NFT, and so on. And also, we may we maybe will. Sorry, I'm losing my words. Oh, okay. Yeah, we have booked the kakarot.stark domain name using StarkNet ID. And with StarkNet ID, you can have free subdomains. That means that, for example, for contributor, we can do something like, for example, lucas.kakarot.stark, and it will be linked to Luca StarkNet accounts. And yeah, this is cool. And we want to experiment that for people that contribute on Kakarot.
Yeah, you can win some great stuff here. We actually won some nice figures.
Yeah.
So you should have participated earlier. I mean, Danilo has won, but others you should have participated before. Here we have a problem, obviously. Joy of rebasing. Okay.
Maybe I can try. I can try to meuble. How do you say meuble in English? To fill the blank basically while you are rebasing.
Well, Well, wait, we have a question. What's required for the airdrop? Do you have an answer for that?
The airdrop. What is the airdrop? Yeah. No, I mean we want to reward builders. So if you want to get something cool, like the best way to do this is to submit a pull request on Kakarot. And I mean, you can also participate in different ways. We have a discussion link in the GitHub repository, and you can basically introduce yourself and say what you want to do. And if you are not a dev, it can be like design, UX. It can be also creating some memes, stuff like that. And yeah. But really, it is more like if you want to be part of an exciting journey to feel the vibes of the builders of the ecosystem and be part of a vibrant community. This is a very cool project to be involved in. So yeah.
Yeah, and it's basically not really an airdrop. It's just you get you get a SBT because you contributed to something. It's I don't know. It's worthless. It's just a roof
to show an achievement of something like that. You have been part of something crazy, something exciting, and yeah.
Yeah, you'll be able to nag your friends because you had something better than them.
Yeah. And also, we say that, but for example, if at some point some community members want to take the lead really on the projects, they can decide to make a real product out of it, and we don't know what it can become. So we just say that, but there is no strict guidelines or rules on the project. The community will decide on the future of Kakarot. So, yeah.
How to get SBT? You need to contribute to Kakarot. You need you just go on the repo, then you check if there is an issue that you might be able to resolve. Then you just ask if the issue is available. Yeah, it should be if it's not assigned to anyone, because we created some strict guidelines about issue resolving, but it's better to ask before so that you don't work on the same thing.
Yeah, and basically you can just jump into the Telegram group, you introduce yourself and you say you want to contribute. And then we have Elias, which is a very active community member that can also guide you through an onboarding call, and maybe we can do some regular Kakarot community call, bi-weekly calls for to onboard multiple people in one call instead of doing only one-on-one onboarding call. But yeah, it's very, I mean, the real treasury is the people you will meet during this journey and what you will also learn. Yeah.
Yeah, like it's not every day that you can work on like a ZK-EVM. And honestly, with Cairo it's really not easy, but it's way easier than doing it in Circom. I don't know.
Exactly.
So this is the opportunity to learn some Cairo, to learn about the EVM, to learn about how blockchain works.
And it will become even easier with Cairo 1.0. And we were joking about it because we said that we wanted to start with this version of Cairo because otherwise we would have done it too fast and we would have been in production before the K-Sync. So yeah, it was a joke, but I mean, with Cairo 1.0, the possibilities will be even higher and we will be able to build even crazier stuff.
Yeah, Cairo 1.0 will like the repo will soon be public, I think, and it's gonna be beautiful. I can show you some snippets.
This is the real alpha, actually. Yeah. If you show a snippet, yeah.
Yeah, I'll show it fast, but
yeah, they will take screenshots and
Yeah, that's fine. I mean, this is what Cairo looks like for now. I mean, it's fine, but still see a lot of things. It lacks a lot of functionalities. And with Cairo 1, you'll have, uh, no, that's not the best example. Uh, haha, this one, I like it. Uh, what, what, I lost the, oh, it's there. Yeah. It's stuck?
Yeah, basically for people familiar with Rust, it definitely looks like Rust. You have pattern matching, powerful stuff like option. So
Yeah.
it really becomes higher level language, and yeah.
Yeah, and yeah, you'll have error handling with, which is really cool because for now you don't, and it's a bit painful to work with that. Uh, there will be also array management, but I don't think we have an example. Yeah, anyway, it's not the subject of the thing. You saw Cairo 1. What programming language are we coding on? Cairo for now. Well, forever. Cairo forever.
But if you want specifically on Kakarot, you can contribute in Cairo, but not only in Cairo. We have multiple components. Like Lucas is presenting the core component, which is the Cairo program that runs the EVM. But we also have other components. First we have a front-end application to interact with Kakarot smart contracts. That means, like, for example, deploy a smart contract on Kakarot and then being able to interact with it. So this is a front-end technology. So basically React, JS, stuff like that. And then we also need, and it has not been started yet, so there is definitely room for contribution on that front. We also need a backend. Why? Because ultimately what we want is something very simple and very transparent for the user. So the end goal is something like that. You add just an RPC endpoint on your MetaMask, and you can think it's a regular Ethereum JSON RPC endpoint, but actually it's not. But it will give you the same experience. And what this backend will do, it will take the Ethereum transaction, the exact same transaction, and then it will do some stuff like adaptation, stuff like that. Then it will forward the call to Kakarot. And then you can imagine a very transparent experience, and you can imagine to play exactly as you would play with an Ethereum smart contract. And for this backend, we want it to be in Rust, and it has not been really started. So there is definitely room for Rust developers to play with it and to kickstart it. And there are many possibilities. Either it can be done from scratch, so you re-implement the logic of an Ethereum JSON RPC, or maybe you can think of forking an actual Ethereum client in Rust, for example, Akula. And for example, Akula actually might be a good option. Why? Because it adopts a modular architecture. So when Ethereum clients started initially, they were like a big monolithic application with everything like the EVM, JSON RPCs, the peer-to-peer, the logic to handle blocks, the consensus, etc. And then the more recent clients like Erigon and Akula, for example, they adopted a more modular architecture. Actually, Erigon initiated that, and they created a specification for modular architecture for an Ethereum client. And what does that mean? It means that you can have different components that are isolated somehow, and it's easier because you can run only the RPC if you want. You can only take the peer-to-peer part, only the EVM, stuff like that. So maybe forking such client will be a good way to leverage existing code. And then we could just add our adaptation logic for Kakarot. So yeah, for REST developers that are listening, feel free to jump in to tackle this backend.
Also, someone is asking how to learn. There are multiple ways of learning Cairo. There are some tutorials that us in StarkNet EDU we have made for you that will teach you how to read and write Cairo code. So this is the link of the organization. Here, this is like the StarkNet Cairo 101 is just to teach you how to read Cairo. So you will have a set of exercises. You'll need to read the code and to reach some instructions to get some points. Then there are these tutorials that will teach you how to write an ERC20 and ERC721. This one will teach you about the messaging system in StarkNet. Basically, you can send a message to Ethereum and Ethereum can send message to StarkNet. This one will teach you how to debug a smart contract, and this will teach you a lot about account abstraction that is native in StarkNet. There are also other tutorials made by OnlyDust and other people that you can also do.
Yeah, and
yeah,
yeah, I have a suggestion for you guys that are listening. If you want to learn and relax at the same time, I suggest you to listen to Henri podcast. He has such a relaxing voice that's crazy. So you can learn and relax at the same time. So yeah.
Yeah, I mean, he said it all. Yeah, it feels there are some podcasts, there are also some workshops. You can listen to Henry your whole life, I think.
Yes.
You'll have enough content. Also, Cairo is like Solidity. No, not really. Cairo is a general purpose programming language, which means that you can use it everywhere else than blockchain. So let's say that you have an AI and you want to train it on Google Cloud, but you don't trust Google, then you write your AI in Cairo and they send the trace and you can generate a proof that everything went smoothly and that they didn't cheat in your AI. For now, it's mostly used for StarkNet, but theoretically, you can use it everywhere. What's the problem? Hi, Elias. How are you?
Elias is here. Tell him
He
to
just
join.
joined.
Tell him to join.
I'll send you the Zoom link, Elias.
Yeah. So Elias is one of the main contributors of Kakarot. So he's not working at StarkNet. He is one of the community members. And he started recently his journey with Cairo, actually. And I will let him explain, but I think it was a great experience for him and a great way to learn Cairo. It was very cool because we were all in the same building at Lisbon for StarkNet CC. There was the Hacker House building. This was another event that was organized by OnlyDust and Brick. It was very amazing. Like it was 4 apartments that there were something like 50 builders in the same building coding. And we were all together with Danilo, Elias, and other community members hacking on Kakarot. And it was like crazy. And yeah, hopefully Elias can join and share his experience as a community member working on Kakarot. Did you send him the link?
Yes, he should.
Okay.
I can join.
I will.
Have to leave.
I will.
Yeah, no worries.
Je vais lui faire un petit coup de pression.
No worries. It's ending in 15 minutes anyway, so please join. All right, we just need to figure out the error.
You're still trying to rebase?
Sort of. I mean, the rebase created conflict because we had modified a bunch of stuff. And here
Okay.
I'm having a weird error.
And really, the best way to learn once you have done the tutorial, once you have done starting stuff like that, the best way to learn is to jump on an open source repo and to contribute. I invite you also to check OnlyDesk platform. They provide basically a platform for contribution. Like when you are ready to contribute on StarkNet ecosystem, you can just go on OnlyDesk and try to find the contribution. Yeah. Elias, welcome. We are happy to have you there. Very cool. I don't know if you listened what we were saying, but basically, I think it could be very cool if you could share your experience as someone that recently jumped into StarkNet ecosystem, and also share the vibes during the event and what you have learned so far, and your plan for the future. If that makes sense.
Sure. So hey everyone. I kind of joined by accident. I wasn't supposed to come. My name is Elias. I'm a software engineer based in Paris. I'm 25, and recently I joined the StarkNet ecosystem as part of StarkNet CC at the same time as StarkNet CC, and met these two wonderful guys. During a week, we hacked at Kakarot, so they introduced me to the project. I had not coded Cairo, or like I had not used Cairo a month ago, so I'm very new to this. So I can imagine if any of you are feeling overwhelmed by this amount of code and this syntax. And yeah, basically, I had to get acquainted with Kakarot, help organize the team effort, contribute a bit. Yeah. Forgot.
And what like, for example, during the hacker house, how was it going? Like, what was the vibes and what was a typical journey in the hacker house?
It was pretty fun. The vibe was pretty cool. The hacker house, we were like 50 people, and 6 of us, approximately 7, were hacking on Kakarot. And yeah, the typical day was waking up, taking an opcode. We have 140 to code to have a complete EVM and a bunch of other things, but mainly we need 140 opcodes. We got 123, if I'm not mistaken, something like this. So yeah, the basic things were which opcodes are next to destroy. We would destroy an opcode. No, I'm kidding. Lucas would, and we would look at him. Yeah, during the hackathon, I think we did 5 opcodes. It was pretty nice, and big ones: store, load. We implemented storage. We implemented deployment. It's pretty nice. We even got a playground going where we could compare Kakarot and the normal EVM, and we had really cool results. So everyone was really happy, and we even impressed some people at Starkware. So it was very, very fun, and everyone was pretty hyped about it. Honestly, it was fun.
Do you have a link ready to demo the playground, or?
I think not, because I'm not sure actually. We should ask them.
Okay, no worries.
Yeah. Do you remember we had a DevNet and then we stopped using it?
Yeah. The famous DevNet of Gregory. Yeah, Gregory is a cool guy. You want to say a few words about Gregory, maybe, or?
Yeah, I think he's contributing to Kgo, the Cairo SDK, the Golang SDK for Cairo. He's a really fun guy. I think you've been working with him, Lucas.
Yes, actually, it was supposed to be about Kaigo. So I'm just gonna say this: if you want to contribute to Kaigo, please do. It's really needed. It's a community project, so we need a lot of contribution. And yeah.
Oh, the workshop was supposed to be on Kaigo.
Yeah, but you know, I'm not really a Golang developer, so I feel more comfortable working on Kaigo.
Yeah,
and
makes sense.
It ends up in like rebasing for an hour, but that's fine.
Yeah, okay. Nice. And yeah, it was and Gregory, very cool guy, but very opinionated on many topics. It was very fun, very crazy, and yeah. And what were the main challenges? Because I guess, you had at the same time to learn about Cairo, but also the EVM. I guess it was new also for you, the EVM. Yeah.
EVM was new because, I mean, a lot of people start Solidity and they learn it, but they never really dig deep into the EVM. So that was my case.
Yeah.
I had done Solidity for 6 months, 1 year, and luckily I knew how like a stack machine worked and like a CPU because I did some classes, so it helped. But honestly, a lot of the times I would just go on the EVM.codes. It's a like a list of all the opcodes, or I would go to internet and be like, what the frick does that do? What is return data copy or whatever? I mean, so many weird opcodes. And
actually, there is a fun story around how you learned about stack machine, right?
Yeah.
You want to share it?
Yeah, sure. I don't know if you guys know Uri and Eli, the CEO and president of StarkWare. So they're very fun, and they're I think they did their studies in Jerusalem, and basically by the providence, I don't know. I used to do late night classes to learn hardware, and it was a free course that I advise everyone to do on Coursera. It's free, and it's called From NAND to Tetris, and it's very, very cool. And yeah, it's taught by Noam Nissan, and I did it like 6 months ago, and then I learned that Noam works at StarkWare. So I guess it was fate that brought me here, guys.
You should check on Wikipedia or something like that. There is you will learn a lot of about Noam. Very smart guy. So yeah.
Very cool teacher.
Very cool. Yeah. And you were familiar with Python, right? Before.
Nah, not really. I was not familiar with Python. I was not familiar with Cairo.
Yeah, not with the EVM.
But you watched some videos for Python, no?
What?
You watched some videos to learn Python, no?
Yes, I did. I was in tutorial hell, and then I got out.
Okay.
And now he's teacher paradise.
Yeah. Let's not talk too much about Python, because otherwise I will start to be not kind. So yeah, let's talk about Cairo.
Anyway, Python will disappear slowly in the StarkNet ecosystem, because right now everything is being re-implemented in Rust. So we have good performances. The VM first, then the sequencer will follow really soon, and probably a bunch of other stuff.
Okay, let's do some kind of pair programming with Elias and Lucas. Lucas, you wanted to implement the call, so I know you are not prepared for that, Elias, but it will be fun. How you will actually implement the call opcode, and is that okay for you, Elias? If you
sure.
with Lucas,
I have to leave in 5 minutes, though. We have 5 minutes to change the world.
5 minutes to let's go.
5 minutes to write history.
Okay, can you explain what you have so far, Lucas, and then Elias can catch up.
If I can remember. Okay, so for call, let's go on evm.code to know what we need. Basically, it's here, and call is somewhere. Okay, so call is here. What we need to pop the amount of gas sent to the subcontext, the address of the contract we're calling, the value of ETH that we're willing to send in this call, the argument offset in the memory, blah blah. Well, we need some stuff, and we're popping it from the stack. So we're using the pop-in function. We're popping the gas, the address of the contract that we want to call, the value, the argument offsets in the memory, the argument size, the return offset that we'll write in the memory, and the return size.
Okay.
Then we create a blank return data, because we need it in the context. The guys remaining child stack. So new empty stack, new memory. Then we compute the memory expansion for the arguments that were popping, because if you're trying to access an unallocated memory cell, you'll need to create it to 0. So we're doing that here. The call data, we're getting the call data. And then we're mapping the EVM address to the StarkNet address to be able to call for the code. And we're creating the child execution context. So we have the nested call depth. So we know in like how many calls we're in. So for example, if contract A called contract B called contract C, we know that we're like in the 3rd level. And it will be useful when we finish the call and that we get to the previous execution context. So what we will do is basically run the execution context recursively with the run function. And once it's finished, we get back to the parent execution context and again and again. Does it look fine for you?
Yeah, got you.
All right.
I think we don't even need to call anything recursively there. It would be handled by subsequent call opcodes in the called contract. What we need to do is to handle the return. This is when we do some return that we need to update the call depths and handle the return data, etc. I think that's fine. We don't even need to call recursively anything there.
Well, the run function will be called recursively, and if we have another subcontext, then we'll run into this function. So
yeah, exactly. Yeah.
Yeah, I see what you're saying. Yeah, so that's the architecture we chose. Do you think it's the right one, Elias?
Yeah, because I had a 5 in my mind, so that's my number 1, of course. No, I think it's pretty cool.
Yeah, and so the implementation is not yet finished because we need to handle the return data everywhere.
Okay.
But right now we would need to test it. So yeah, but I think we're running out of time. So this
Now, how can you test it right now? Because you declare child context, but you return context.
Yes, no. So this is not finished.
Okay.
So we need to finish it and then test it. And it's easier, to see if our implementation is good if we test it.
Yeah, definitely.
Yeah, but this could be an issue if someone here wants to do it. You can say it and we'll open an issue. Otherwise, we'll do it ourselves. You're choosing.
Yeah. Might not be the best one to jump in as a first issue, because it is quite complex, but yeah.
But it could be fun if we open up pair programming sessions, by the way. We should maybe think about it. Because it'd be very fun, and we could even stream it or something, where Lucas would take on someone for an hour and maybe that person can and he could
we can try with Danilo.
Yeah, with Danilo or
you or
myself.
Fresh
I could even do it.
Yeah,
anyway.
That would be super cool, actually.
Then that way we have to explain out loud the code.
And would you be willing to? We were thinking about doing some Kakarot specific community call, maybe bi-weekly. Would you be willing to animate some of them and maybe to onboard contributors instead of doing only one-on-one? For example, if you have 10 people on the same live stream, it's easier for you to explain them how to jumping, stuff like that. I don't know, just a random idea, but
it could be fun. Yeah, sure, it could be fun. The live coding would be fun, and definitely streaming it would be even funnier.
Yeah.
Awesome. Very cool. Can we take some questions from the audience?
Yes.
I have to go,
if you have
guys.
To run, yeah.
Okay, bye. Yes.
See you soon. Thanks for coming.
Thanks for having me. That was very random. That was fun. Hope to be back soon.
Yeah.
And guys,
All right.
laters.
When do you finish the
It's
workshop?
supposed to be finished now, but we can take some questions.
We can take, okay, I want...
So the question is, where is the output condition for the recursive function? When we match, like, basically the recursive function is run, which is somewhere in the library. Yes, it should be there. Where is it? Okay, it's here, and you see if stopped equals true, then we return, like, we stop. That's the end condition. Danilo, I have many questions. Ask them. We'll be glad.
Danilo is here.
Yeah, Danilo is here. Do you want to come,
Tell
Danilo?
him to join. Yeah, tell him to join.
Okay.
I was just actually I was just pinging him on Telegram to say him to jump in. Okay, jump, my friend. Let me.
I'll send you the link.
He's coming. Nice. No, in English, he's coming. Can have another meaning. Okay, sorry. He's jumping.
Oh, you're a kid. Now that it's recorded, it's not just a live stream.
Oh, yeah, I forgot. Shit. Okay. Yeah. You don't do any cut or any editing before publishing it on.
I personally don't. But
okay, you put it as is. Okay.
Yeah, I think
nice.
It's just like the replay of the stream, so that everyone can see.
Nice. I will be flagged as a kid. Yeah. Very cool. What was the question about the recursive function?
Where is the output condition of for the recursive function?
Okay, so you explained that it is not a direct recursive function, but
yeah, it's the run function that's recursive, and that checks if we reached actually, well, this one does not. Yeah, if we reach this subcode, which is stopped. Also, we didn't mention it, but we have an ERC20 that works.
Oh, Abba, Danilo is the best person to explain that. Hey, Danilo, glad to see you.
Hello. Yeah. Good to see you too.
Hi, Danilo.
Yeah.
Hey, Lucas.
Yeah, so Danilo is one of the main active contributors on the community. And basically Lucas was mentioning that we achieved the grid to milestone, and you are the best to explain it because you actually did it during ETH San Francisco. So maybe you can explain what you did during this event. And
Yeah. So on ETH Lisbon, we worked on deploying a simple contract, which we wrote ourselves. And then for ETH San Francisco, we thought about why not now try to deploy a Solidity compiled contract with all the init code and the runtime code being separate. And that's what we tried. And basically our approach was put it to test. Whenever it breaks, try to fix it until it runs all the way. And it worked. And yeah, overall, it was an amazing experience. So we were able to deploy a fully functional ERC20. There are some improvements, a lot of improvements to be made. But I just wanted to thank Lucas and Abdel, as basically we are building on top of what was structured by them. So just by looking at it, I got to learn a lot. And definitely this wouldn't be possible without last week's, like everyone coding together, sharing knowledge, we asking a lot of questions to you guys. And yeah, so thank you so much.
Yeah, but no, it's definitely amazing to see the vibes of the community and how, like, I was saying that before, but during the hacker house in Lisbon, it was like crazy. We were all hacking together. It was like 4 a.m. at some point. We were all exhausted, and it was so fun. And I enjoyed a lot this time with you guys. So it was crazy. And this is something very special that we see on StarkNet. there is a strong community and the South that is emerging, and this is very cool. I always say that, but it reminds me of a quote from Vitalik, which is saying that $1 billion capital project cannot compete with a project with the South. And I think like we have a South on StarkNet, and this is amazing. So glad to see that. Did you enjoy the Hacker House at Lisbon? How was it basically? How were the vibes? And
Yes, it was an amazing opportunity to be around so many amazing developers. Like you mentioned, I think the Starkware community, all of them are big brains. To everyone you talk about, they're doing something like, oh, like that's amazing. And basically staying a whole week with all these amazing people, I think like you cannot find it anywhere else. And I think like it's not that it's just a lot of smart people. It's also like a very united community, maybe because we don't have more than 1,000 people. And because of that, I think the interaction and the connection level is a lot deeper than many of the other events. So I was very inspired and very excited during and right now after the Lisbon Hacker House. Looking forward for more.
Yeah, very cool. And I think like Sil from Brick said it well during the StarkNet CC event. He was basically talking about the history of StarkNet, and he was insisting on the fact that this is the history of people on StarkNet, and the fact that StarkNet is strange and we should keep it strange. And I like it actually. This keep StarkNet strange meme is very cool and very powerful, because I think it was part of the success of this community and the fact that they are all united, because it was so painful at the beginning to do some Cairo. They were united under the same pain, and it was crazy. And also the fact that they had some new primitives that don't exist anywhere else, and they just had new weapons to play with, and that means to me that they were used to think out of the box, and this is cool because in terms of innovation, we don't have like just random copy pasta of what we have on Ethereum or other project, and I love that. So yeah. In terms of the next step for Kakarot, when do you think like we can have a full working Type 3 EVM with all opcodes, roughly, if you had to guess?
Oh, my guess?
Yeah.
The fully working ones, I think you guys are taking the challenge on the remaining harder ones, which I think is the caller, and then there would be the create and create two, which I think will have the similar issue of having to recursive like on the loop. Once we have that, I think it's possible to start testing out more complex contracts. And I think that in a timeline, I would say maybe in 2 weeks to 4, we would definitely be able to I think run and test a lot of more complex contracts. So having a fully version 1 optimized and user ready, if I think things keeps going on the vibe and the path that we're going, I would guess like in 2 months, we should have.
Okay.
It would be a good time to. Maybe even earlier, I don't know. But I think it will depend on the optimization. I think the optimization will be the most challenging part to make it very user ready. The parts of the opcodes and running contracts, I think you guys already have done so much that most of basic contracts should be able to run normally on top of the Kakarot EVM in 2 weeks.
Okay, Very cool.
I would be
Awesome.
a bit more pessimistic than that, because there
Yeah.
are always, problems that we can't imagine that might lead, to some big delay. But I like
No,
it.
but I was talking about like a naive implementation, so not optimized, and also for nominal cases, not edge cases like handling a proxy contract or whatnot, like just nominal cases. But like, for example, we are close to that. I mean, with ERC20, we start to, like, for example, the next step can be an FT, and then the ultimate step for me is Uniswap V2. If you can deploy two ERC20 and Kakarot and then do a swap, that's crazy. And then we can start to think about optimization and all this kind of stuff. But yeah, it will be a long way to go for the optimization round. I guess we will have some surprises in terms of efficiency. Obviously, we will have to imagine a lot of optimization tricks, but it will be funny and exciting, I think, and challenging. But yeah, we were talking about the packing. Maybe Danilo, you want to explain the problem with
Oh yes,
how
yes.
yeah.
So I think Prashant is here also, and Prashant, I think he definitely could give us a hand, as he's a chip designer. So the issue today is that we have an array of fields, and each element of the array is 1 byte. So it's two hexadecimal values, and basically we are underutilizing the whole felt. The whole felt can have up to 31 bytes, but we are just storing 1 byte. And because of this, we are having to store or initiate 31 times more memory compared to the steps that we would be able to if we could have 31 bytes in one felt. And the trade-off, I think, would be how efficient because there's a lot of calculations and paddings and filtering out specific bytes, and how these functions that Abdel mentioned, that if it's developed, how efficient they are compared to having more bytes or having to have more memory slots. My guess is that 31 times less memory slots will outwork some inefficiency in processing, but that's just a guess. And yeah.
Okay. Lucas, what do you think about that? What is your guess in terms of the trade-off between saving a lot of memory space versus adding some computation? What is your gut feeling about that?
It would definitely reduce the code of the cost of storing the bytecode on chain. But for the number of steps, I'm not sure it would improve that many, because we would need to use the bitwise built-in, and I'm not sure how more efficient it is than just copying everything, using just a field. I don't know. I think that, yeah, I don't know.
Okay, it will be interesting too. This is definitely something to experiment, and it can be done separately. I mean, you don't have to have this EVM logic to benchmark this. So if anyone wants to test this from the community, feel free to jump in. And I guess this will be useful. Luca, also regarding the problem we had with the constructor contract, there is no way to do some kind of multi-call directly from the smart contract, because the problem Danilo had was to be able to deploy the StarkNet contract with the EVM bytecode, and then directly being able to run the constructor function to init.
Well, you can do that.
You can or you can't?
You can.
How?
When you deploy it and then you call the constructor.
In the same transaction?
Yeah.
Okay. Then maybe we need, yeah.
So the issue I had was to, when I tried to deploy and change the state of that contract on the same transaction, it was basically saying that contract was not found because it wasn't deployed yet. So my guess would be that if we could run the EVM bytecodes on the StarkNet contract, in the StarkNet constructor, then that could be a solution. But yeah, I did have this problem of when trying to, at least how we implemented as store today, which is a call on the storage of that contract. It would just give this error that the contract doesn't exist yet when trying to call in the same transaction. But I could be wrong, and there could be more other solutions.
Do you think it should be possible, Luca? Like,
Yeah,
for example, Kakarot deploy a contract, and then it invokes.
Yeah, it should be.
It should be okay.
I would need to investigate if you're saying that it does not work, but
yeah, I think it's worth exploring because it has some impact on the architecture for the moment, and we need to do some tricky stuff that if we can remove those, it will be better. Yeah. Okay. Amazing. Are there some questions in the chat?
No, I think we can wrap this up.
Okay. Thanks, Danilo, for joining us, and
yes,
thanks
you
again for your
invitation.
contribution. Yeah. See you soon, Danilo.
Thank you.
Bye.
Thanks, guys,
Bye.
for coming.
Yeah. Thanks. Bye. Bye. Yeah.
Yeah, so we're gonna wrap this up. Thanks for coming. Don't hesitate to reach out if you have some problems, if you want to learn Cairo. You can reach us in the Discord or in Telegram. Yeah, basically feel free and keep learning. It's important.
Bye.
Bye.